Water Resources Engineering 2, Unit 1, Gravity Dam. So, effect of horizontal acceleration, and now that can be divided into the two forces. This is the horizontal inertia forces and hydrodynamic forces. So, horizontal acceleration acting towards the reservoir, so causing a momentary increase in water pressure. As the foundation and dam accelerates towards the reservoir, and water resists the movement due to this inertia. So, the extra pressure exerted by this process that is known as the hydrodynamic pressure. Okay. So, now in first figure that will show the dams in empty condition, and the second is shows the means dam in full condition. So, this is the burst case in horizontal direction, in burst case burst combination for a reservoir empty condition, that is horizontal forces is acting towards the reservoir and vertical upward, as well as in full condition the horizontal acting towards downstream and vertical is acting upward. Inertia force in the body of dam. So, the horizontal acceleration produces an inertia force in the body of dam. So, this force is generated in order to keep the body and foundation of the dam together as one piece. The direction of the produced force will be opposite to the acceleration imparted by the earthquake. So, horizontal inertia force equal to the product of the mass of the dam and the acceleration in horizontal direction. So, this is comes out the inertia force means mass means W by G into the acceleration in horizontal direction, that is the alpha h. So, where this W is the weight, total weight of the dam. So, if suppose this alpha h is taken as a kh into g, where kh is the fraction of gravity adopted for horizontal acceleration such as 0.1 or 0.2. So, this force should be considered to be acting at the center of gravity of the mass, and it acts horizontally towards downstream in worst case for the reservoir full condition, and this inertia force is acting in upstream direction when the reservoir is empty condition. The hydrodynamic pressure force. Theoretical calculation indicate that the distribution of hydrodynamic pressure due to an earthquake on upstream face of the dam is nearly parabolic. But according to the USBR, now recommendations may be used to evaluate the pressure intensity due to the earthquake, assuming elliptical cum parabolic distribution of pressure. So, according to the Jenger formula, the pressure intensity means is PE, small PE, that will comes out the C KH gamma W into H, where this PE, small PE, pressure intensity in kilonewton per meter square or ton per meter square, and KH is the horizontal earthquake coefficient, that is 0.1 in earthquake intensity of 0.1 G. So, this is the fraction of gravity, and gamma W is the unit weight of water. This is the taken as a 9.81 kilonewton per cubic meter or 1 ton per cubic meter, and H is the maximum depth of the water in meter, and C, that is the coefficient. And this coefficient now that can be found with the help of the relation is given. The capital C is equal to Cm by 2 y upon h in bracket of 2 minus y upon h plus under root of y upon h into 2 minus y upon h. So, here this y is the depth in meter from the top of the reservoir to the point under consideration, and the Cm, that is the another coefficient. So, the Cm, that is the 0.735 theta upon 90 degree. So, that will depending on the upstream slope. So, theta is the angle in degree that the upstream slope of the dam makes with the horizontal. When upstream face is partly vertical and partly sloping, so there are two cases that can be arises. Here, when the vertical portion is more than half of the depth, so the entire face is vertical. So, theta is taken as a 90 degree. So, means the slope is neglected. But in case of when the vertical portion is less than half the depth, so the overall slope up to the whole height may be taken as a value theta in above equation. So, this theta is taken from the heel to the water surface. So, line joining from the means water surface at upstream and it will joins to the heel. So, this is comes out the theta. So, total pressure capital PE on the portion of the dam up to the depth is H. So, this is capital PE means 0.726 small PE into H. So, the moment ME about the plane up to which the pressure is taken is given by, that is the ME is equal to 0.299 small p, this is the pressure intensity, into H square. So, now put the value of small p in terms of capital PE means hydrodynamic pressure force. So, it will comes out the 0.412 capital PE into H. So, this is the moment about the base. Now, comes to the another means method for determination of the moment about the base due to this hydrodynamic pressure. Now, by the Born-Kármán. So, the basic assumptions for this method, the upstream face is taken as vertical. So, hydrodynamic force PE, that is given by 0.555 kH into gamma W into H square, and it acts at the height of 4h by 3 pi above the base. This is the means if this multiplied with the force, so that will comes out the moment of this force above the base. So, m e is equal to P e into 4 h upon 3 pi. So, this will comes out the 0.424 P e into h. So, a horizontal acceleration towards the reservoir cause a momentary increase in water pressure as the foundation and dam accelerate towards the reservoir, and the water resists the movement due to its inertia. So, thus the force is taken acting in the opposite direction of the earthquake acceleration, and similar pressure will be developed on the downstream tailwater when the earthquake is reversed. The next forces on gravity dam, that is the forces due to the waves. When wind blowing over the reservoir area causes a drag on the surface, so the effect of the drag is to pull the top surface along the direction of wind, and thus ripples and waves are formed. So, waves are generated on the surface of the reservoir by the blowing winds, which extra pressure towards the downstream side. So, waves pressure depends upon the wave height. Wave height may be given by the according to the Molitor-Stevenson to evaluate the height of wave. So, when the f means fetch, that is less than or equal to 32 kilometers. So, height of wave means hw, that will comes out the 0.032 under root of v into f plus 0.763 minus 0.271 f ki power 1 by 4. Now, if in case of the fetch is more than the 32 kilometer, so height of wave is comes out the 0.032 under root of v into f, where the hw, this is the height of wave in meter, and the v is the wind velocity in kilometer per hour, and f means fetch or straight length of expanse in kilometer. So, now this f that will shown in figure means due to the construction of the dam. So, then the reservoir is the formed. So, means this is the straight length of water is expands from the dam. So, this is the means this straight length that will shown the fetch length, and this value is less than or equal to or the more than is the 32 kilometers. So, accordingly now this formula that can be used. So, the maximum pressure intensity due to wave action may be given by the small Pw, this is the pressure intensity due to wave, this is the 2.4 into gamma w into hw, and this act at hw by 2 meters above the still water surface. So, the pressure distribution may be assumed to be triangular of height the 5 by 3 hw, that will shown in figure. Hence, the total force due to wave action, that is the capital Pw. So, Pw that is comes out the 1 by 2. So, area of this pressure diagram due to the waves 1 by 2 into 2.4 gamma w into hw and multiply by the 5 by 3 hw. So, then it will comes out the 20 hw square kilonewton per meter length of the dam, and this force is acts at a distance 3 by 8 hw above the reservoir surface. Means the capital Pw is known, and this force is acting, if suppose the moment is taken about the toe, so then the capital Pw is known. So, capital Pw into capital H means this is the height of water plus 38 Hw. So, this will comes out the moment, and this moment having the direction is the clockwise. So, this is the disturbing forces. The other forces which is acting on the gravity dam, that is the silt pressure. So, when the dam is constructed, the silt get deposited. So, dam is therefore subjected to silt pressure in addition to the water pressure. If the gamma submerged is gamma submerged, that is the submerged unit weight of the silt, and phi is the angle of internal friction, that is also known as the angle of repose, and small h, that is the height to which the silt get deposited. So, the silt pressure is given by the P silt, capital P silt means force, that will be 1 by 2 gamma submerged into h square 1 minus sin phi upon 1 plus sin phi. So, this is the K means this is the active pressure coefficient, and it acts as a h by 3 from the base. So, if the upstream face is inclined, so the vertical weight of the silt is supported on the slope and also act as a vertical force. So, as per the USBR means United States Bureau of Reclamation recommended followed in the design is to consider silt pressure as a fluid pressure, which creates a horizontal pressure with its intensity equal to 3.6 kilonewton per meter square, and vertical pressure with a density that is the 9.2 kilonewton per meter square. So, thus the total horizontal pressure will be equal to 3.6 h square by 2 means 1.8 h square kilonewton acts as a small h by 3 from the base, and the vertical pressure will be equal to 9.2 into area of the triangles of the silt multiplied with the 1 meter, because this 1 meter considered as a 1 meter length of the dam, and these pressure are means this pressure is acting at the CG of this triangle. So, these pressure are in addition to the usual pressure. Now, then the ice pressure. So, at high altitude or the cold countries, reservoir get covered with a sheet of ice due to sudden increase in temperature of atmosphere. The temperature of the ice sheet also increase, and a thrust is caused by the expanding tendency of ice sheet. So the dam face has then to resist the thrust exerted by the expanding ice. This force acts linearly along the length of the dam and at the reservoir level. So the magnitude of this force varies from 250 kilonewton per meter square to 1500 kilonewton per meter square depending upon the temperature variation. On an average, a value of 500 kilonewton per meter square may be allowed under ordinary condition. Acts on exposed area.